would like to welcome you to that final event of the Blackcycle project. So just to remind you, the project started in 2020, April 2020, and it will end up in June 2024, in 1 month.
So good morning, everybody. Thank you all for being in Saarland today, hometown and home region of Pyrum. That's the main reason why we are here.
Good morning to everyone, also online. My name is Simona Maassen, and I'm the Government Affairs Director at Orion. And I will be your moderator for the day.
Good morning to everyone. I'm Floriana Lamarca. I'm the PO Project Officer of Blackcycle on the European Commission side. We received EU funding to implement the topic for reuse, recycling and recovery schemes. It received almost 12 million euro, corresponding to about 75% of the total cost of the project. The EU is strongly contributing to circular economy project. We wish you a very good work today, and let's stay in touch.
We started by the fact that there are about 1.6 billion of tires that become waste every year. And if you convert that into materials, that means 31 million tons of material per year are becoming waste. So 90% are collected in the world, and they are valorized either in energy or in material. If you look at the situation in Europe, the number are almost smaller, and we are talking about 3.5 million tons of ELT. ELT means end-of-life tires, and it's per year. The system of collect in Europe is very well organized. We have 3 systems, so you see the different countries applying the different systems. In green, that's extended producer responsibility. So a lot of countries like that are like that. We have also a liberal system, so that means it's a free market to get the ELT. So like, for example, in Germany. And we have also the tax system. It's a government responsibility through a tax, financed through a tax. And the rate of collect is very high because it's 95%. And in Europe, about 40% of that ELTs are valorized in energy and 60% in material. So what we saw at that time in 2020, I said, okay, 40% are valorized in material, but indeed a small amount of that went to tires, because the quality of the secondary raw material made from ELTs was not good enough to be put back in tire without impact on the tire performance. And the second thing that we saw is that there is a possible ELT feedstock that exists, because in fact, if you look at the situation in Europe, you can see that roughly 50% of ELT are exported outside Europe. So we thought that it could be a good feedstock for us to be transformed in something in material that will go back to tires. And you probably are aware of also recent regulation. It was not in 2020, but more recent, constraint about granulate used in artificial turf, sport and children playground, that will also release a part of the feedstock, maybe for us to transform it in raw material that we could use in tires. So starting from that, we saw that there was a great potential for material recovery in tire at the beginning of the project, if and only if technologies were available to make high secondary raw material tires to be introduced in a high quantity in new tires. But if you look at the challenges that you have when you want to replace a fossil raw material with a recycled raw material, you have 4 main challenges. The first one is to find the good technologies. Because as I said, if you want to put a raw material, secondary raw material in a tire without impacting the tire performance, you need to have technologies to get high quality raw material. And that means that if you start from ELT, you need to have good technology of transformation of the ELT to get the high secondary raw material. Because the tire is extremely technical, and there are various performances at the same time that you have to keep. So the first challenge was finding the good technologies. And here, in our case, that was the technologies of the process, the transformation of the ELT. The second one is, when you have the technology, it's not over, because you need to create the supply chain. because here we are talking about a lot of material. In fact, well, if we see the consumption of raw material worldwide by Michelin, it's more than 3 million tons of raw material, so that's huge. So you need to create a supply chain that can produce large volume with a good quality and stability of the quality. The third challenge is economical viability. And so we were pretty sure that we will have something more expensive, and we will compete against fossil raw materials that are very well optimized. And here we will have a new value chain with investment, with productivity that will be not optimized at the beginning. So we knew that there will be a gap in terms of cost. And so economical viability is something very important for the creation of this value chain. The last challenge that we had is environmental viability. We need to be sure that if we move away from the fossil raw material with a new value chain, we need to have a positive impact on the life cycle assessment. We need also to be sure that in terms of energy balance, it goes to the good direction, less energy. And also we need to be sure that we don't create new negative environmental effects by creating a new design, a new value chain. So we had 4 big challenges, and so we said, okay, Michelin cannot do that alone, so we need to find the good partners to do it. And the best way was to launch a project, and a European project, so co-founded the European project with a consortium, and gathering all together all the skills that we needed to succeed in those challenges. And so this is what we did. And so we launched a project, the project Blackcycle, and we put together all the skills that we needed. So you have here all the partners. There are 12 partners plus Michelin, so that's 13 partners, in fact, and Michelin is the coordinator. And we have the different skills around the value chain that we created. So from the collect to the production of the raw material, carbon black, resin, and so on. And also all the process that were necessary to transform ELT into a secondary raw material. So we have 13 entities coming from 5 countries. So this is a very international project, very interesting for that as well. So the Blackcycle project, just to remind what we wanted to do. So we wanted to create a massive tire circular economy, so tire to tire, and by developing the technologies to make high quality secondary raw material from ELT for new tires. So that was the goal. We had some key objectives. We wanted to valorize 100% of the ELT that would be selected to go through the chain. We wanted to increase up to 10 times the SRM rate into a new tire, and we wanted also to decrease the CO2 emission at least by 50%. And all of that being viable in terms of economic and environmental.
I'm very happy to be here today because, as said Jean-Michel, some of us, we are working in Blackcycle from 5 years. Yes, more than 5 years. So I will take 1 minute at least to say thank you to all the partners and even Europe to give me the possibility to work in this great collaborative project and present today the great result of this project. The objective is to deploy end-of-life tire value chain to deliver validated high-quality secondary raw material, but as well delivering the technology package to produce this raw material. For that, Blackcycle imagines a global value chain, and today all the partners will explain you each part of the value chain. So I will go very quickly in detail. The first level to optimize and develop this full value chain is the deconstruction of the tire. Why? Because tire is a complex product that have different kinds of rubber and different kinds of material. So the first level say, okay, if we deconstruct the tire to have the best value to improve mechanical recycling, producing micronized rubber powder in one hand, as well high quality rubber to increase the pyrolysis process. So Thomas and Alexander will explain the work done in this part today. The second part, and is the core, the heart of the process, is to optimize the pyrolysis. Pyrolysis is well known because Pyrum and Systener have the old technology and the know-how, but the objective of Blackcycle is to optimize the pyrolytic condition to produce high-quality recovered carbon black in one hand, on the other hand, to optimize the oil. Why? Because the objective is to upgrade in this oil in Blackcycle to produce different sustainable raw material. In the first time, Systener and ICB have worked in distillation to produce, on one hand, heavy tar tire, that is the name for the heavy part of the pyrolytic oil, yes, to produce with the Orion process sustainable carbon black, that is same carbon black with the same quality as ICM1 or Q1, yes, and the objective to develop this process at the validated at the in the second hand, with this uprising process and distillation as well, we will valorize the light fraction of the pyrolytic oil to produce resin, hydrocarbon resin and plasticizers for tire, yes, and as well other kinds of pyrolytic oil and heavy basic stuff. At the end, all these sustainable raw materials as resin, sustainable carbon black, recovered carbon black, and micronized rubber powder, Magali will work, and Michel in rubber team will work to optimize the composition of the tire to keep always, as said Jean-Michel, the same performance of the tire, to increase significantly the secondary raw material rate in the tire. The objective is to have 10 times more than today, so it's a big challenge. So to robust all the value chain, we know that we have to valorize 100% of the end-of-life tire that entry in the value chain. So we will work in the other valorization of the product and as well of the product, because it's a key point to be sure to the circular economy be a reality, to produce sustainable carbon black for tire, but as well to have a value chain robust.